My name is Timothy Nemicus, and I'm from the Episcopal School of Baton Rouge in Baton Rouge, Louisiana, in the United States. I used machine learning to statically analyze benign JavaScript for cross-site scripting vulnerabilities. Cross-site scripting is some of the most common web vulnerabilities, yet it's also some of the most difficult to prevent. It allows malicious actors to run code on a user's browser, stealing their personal information. Currently, the best method of detection is dynamic analysis, but it comes at the cost of high resource consumption that makes it unlikely to ever see wide-scale consumer deployment. I created two machine learning models, a random forest decision tree and a deep neural network, to find cross-site scripting vulnerabilities in code samples. To convert the code samples to vectors for the models, I used two hash functions, which map tokens in a sample to columns of a matrix. I found that a deep neural network trained on a term frequency inverse document frequency hash function maintained the highest precision at high rates of recall. At 99% recall, 1% of the vulnerable samples slip through the cracks. At this recall rate, the best model obtained 43% precision, which is a false positive measurement. I also performed Lime analysis on my best model to better understand why it made the predictions it did, which is important for understanding how it would work on deployment. And I got mixed results. While the model is correctly identifying historically vulnerable JavaScript code, it may be heavily influenced by other random tokens. We can use the system presented in this paper in tandem with dynamic analysis. By filtering a website first with static analysis, dynamic would theoretically need to check 242 times less functions, which would make it possible for in-browser detection of cross-site scripting vulnerabilities.